What is science? More specifically, what is science from my perspective? Is science about conducting laboratory experiments? Maybe it's about the accumulation of knowledge and facts. Or maybe one could say that science is about exploration of the unknown. Science is all of that. Science is hard to define precisely, but if we wanted to put a hard definition to the word, we could say that science is about exploring unknowns of the physical world, looking for evidence in order to build up a collection or database of knowledge and facts. As undergraduates and students, we tend to focus on the building up of personal knowledge from pre-established knowledge, i.e., we are taught. However, a transition occurs somewhere after the formal years of training, where we move from the student to the professional. We move from simply absorbing pre-established facts to also probing into the new and the unknown. As professionals, we continue to gain personal knowledge while also working to add to the database of global knowledge. I entered the production world of chemistry as a mass spectrometrist about 10 years ago. In this field, I've trained in the use of analytical techniques to evaluate samples in a quantitative and qualitative manner. Today, I work in the same field as a mass spec service engineer. As such, I am trained to take a mass spectrometer, break it into its component parts, and evaluate those system components to repair and assist the scientist. Together, the components function to provide the apparatus, or as we like to call it in the scientific community, the instrumentation, to evaluate samples and determine what is in those samples. Samples come from many sources. They can be natural products, illicit, and legal drugs, biological specimens, non-biologics. The samples enter the lab in either a solid or liquid form, and then we take each sample, homogenize it, filter it to remove solid particulates, and then purify the samples to remove as many impurities as possible. When we utilize our mass spec instrumentation, it's typically in tandem with a liquid chromatography system, or LC system. This LC system takes advantage of the physical properties of component molecules that behave differently when exposed to a solvent environment in order to separate the component molecules based on their polarities, their size, hydrophobicity, pH, and many other factors. So we inject that liquid sample into a high-pressure reverse phase chromatography system that utilizes a flow of two primary solvent mixtures. These solvents, which we typically call solvent A and solvent B, pumped through the system in a gradient fashion, help to separate the compounds or the molecules over a period of time. The solvents take the injected sample and flush it onto a silica-based column. There, the samples are separated based on affinity for the column material versus the affinity for the mobile phase. Like I said earlier, that spreads the samples over a period of time. The entire gradient run from an LC is eluted and then injected onto the mass spectrometer. If we look at this second piece of instrumentation in tandem to the LC, we can see that the mass spec takes a liquid sample, it vaporizes it at the source using heat, it applies a high voltage to the sample spray in order to ionize or add a charge to the molecules, and then these ions are swept into the vacuum chamber via electric charge and gas flow. Curtain gases keep the excess non-ionized vapors from entering the ultra-high vacuum optic chamber because they flush against the ion path. Utilizing a series of voltages arranged in a gradient fashion along with RF voltages, the ions travel down what we call a quadrupole path. It's called a quadrupole because this has 4 poles. The RF alternates between the pairs of rods and helps to send the ions of interest in a spiraling path towards the end of the poles and to the detector. During their travel, the ions are focused via lenses, and along with the appropriate set of RF, non-interest ions are crashed out of the path. Most quadrupole mass spectrometry today is conducted utilizing what is known as a triple quad system. In other words, there are 3 sets of rods: Q1, Q2, and Q3. Yes, scientists are very novel in the naming nomenclature. Utilizing voltages in Q2, further fragmentation of the ions produced in the source and selected for in Q1 are produced. These secondary ions are selected for in Q3, and together with Q1 ions are collected as pulses on a detector at the back of the MS system. The detected signal is collected and displayed graphically via a mass to charge versus intensity display. We call this a chromatograph. In a nutshell, data can be extracted from this to determine unknowns when we compare it to library searches, and we take the intensity to determine concentration of analytes in the samples submitted to this analytical mass spec laboratory. We can take all of this and say that working in the field of mass spectrometry allows me to contribute data to the field of analytical mass spectrometry. More broadly, the data, which is novel information, helps to build the broad knowledge of science. Each discipline within science helps to build upon the other ones and contribute to the vast conglomeration of scientific knowledge. And this is what science is to me.